Hi all, my name is Catherine, Assistant Professor from the Department of AAML, SNS College of Technology, Coimbatore. Today in our lecture series, we shall see about the division algorithm. Earlier we saw about the linear congruential and generator and the Blum sub generator, that is nothing but the pseudo-random generators. So since this unit is all about number theory and public key crypto systems, here under number theory, we should know about the basic division algorithm in order to learn about the more algorithms in future. So this will be like a basics for all your algorithm. So I hope you all know what is the division algorithm, which we have learned from our earlier school days itself. So with this comes with certain notations and formulas, which we'll be using frequently in our cryptographic algorithm. So the notation B/A is commonly used to mean that B divides A. So also if B/A, we say that B is a divisor of A. So given that which applies only when the given integer should be both of the input should be positive integers. For example, if you say 3/6, you should understand that 3 is dividing 6. So 3 is the divisor and A is the dividend here. So if we divide A by B, we get an integer quotient. Quotient will be Q and a remainder R. That should obey the following relationship. A is equal to QB plus R, where R should lie between 0 and B, and Q is nothing but the quotient. When you divide A by B, the quotient is Q and the remainder is whatever you are getting, but it should lie between 0 and B. For example, A is equal to 21 and B is equal to 2. When you divide 21 by 2, you get a remainder as 1. So you can write it as how many times 2 will divide? 10 times it will divide. So 10 into 2 plus 1, so you get 21. So R is equal to 1 and R is between 0 and 2. You should understand that R should lie between 0 and B. This is all about the division algorithm. Next, we have an important algorithm, Euclidean algorithm. Euclidean algorithm is nothing but it is basically used to find the GCD of two numbers. So GCD is nothing but the greatest common divisor of two positive integers. For example, if you are given two integer numbers, you should find out which is the common divisor. Also, it should be the greatest common divisor. So the algorithm goes like this. The algorithm for finding GCD of A comma B is as follows. If A is equal to 0, then GCD of A comma B is equal to B. Since the GCD of 0 comma B is B only. So GCD is nothing but the greatest common divisor. So if A is 0, obviously B will be the greatest common divisor. So if B is equal to 0, obviously A will be the common divisor and you can stop there itself. You can stop the algorithm there itself. Write A in quotient remainder form like such that A is equal to B into Q plus R, as I told you in the division algorithm. So next you have to find the GCD of B comma R using the Euclidean algorithm. GCD of A comma B is equal to GCD of B comma R. This will be more clear when I show you with an example. So here you are given two numbers. Find the GCD of 270 and 192. A is equal to 270 and B is equal to 192. Now you know that A is not equal to 0 and B is not equal to 0. So you can proceed using the long division method. You divide 270 divided by 192 with a remainder of 78, the quotient of 1. We can write this as A is equal to B into Q plus R. So here A is 270. 270, how you can write? 192 into 1 plus 78. So next, find the GCD of this 192. So here this 192 will become A and 78 will become the B. 192 comma 78. So you check A is equal to 0, B is equal to 0. It's not equal to 0. So you keep proceeding. You divide it using the long division method. And here you get the quotient as 2 and the remainder as 36. And you write it as 192. How you can write? 78 into 2 plus 36. So next step is A will become 78 and B will become 36. You keep doing until you get A or B is equal to 0. So when you find GCD of 6 comma 0, A is equal to 6 and B is equal to 0. So what do you get? When you know that if any of the number is 0, you have to stop your algorithm there and the rest of the number will be the greatest common divisor. So here GCD will become GCD is equal to 6 it will become. So as we have we have shown it as GCD of 270 comma 192 is nothing but 6. How did you achieve this? You kept on doing GCD of 192 comma 78, GCD of 78 comma 36, GCD of 36 comma 6, the GCD of 6 comma 0 until you receive any one of the number is 0, and you stop that algorithm. This is one of the algorithms which is used to find the greatest common divisor, and the common divisor we got is 6. So I hope you all understood this algorithm. Thank you.